Most of us can attest to the difficulties of seeing pavement markings while driving in rainy conditions at night. A technology developed by 3M features optical elements that can retroreflect light underwater, which greatly increases pavement marking visibility in rainy conditions. This technology is termed all-weather paint and is supported by the Federal Highway Administration through a project under its Highways for Life Technology Partnerships program. The goal of the project is to develop a version of the technology for construction work zones. Here is a demonstration of this technology compared to conventional glass bead and paint type pavement markings. First is a simulation in a controlled environment with a rain simulator. The rain simulator features sprinklers that provide 1 inch per hour rain on the pavement markings below them. Of the two pavement markings, the one on the left is 3M all-weather paint, and the one on the right is a conventional pavement marking with paint and glass beads. The samples are about 3 meters in length. The camera is located 30 meters from the markings. First is a simulation of daytime visibility, where the markings receive diffuse light coming from various directions. In such daytime conditions, the visibility of the markings is very similar. At night, the situation is quite different. Once the diffuse light is removed and headlamps near the observer provide illumination, visibility almost entirely depends on the respective retroreflective characteristics of the pavement markings. Initially, both pavement markings are dry and both are visible. As rain starts falling onto the markings, the retroreflective capacity of the conventional pavement markings decreases substantially. Within 1 minute, the visibility of the conventional markings greatly deteriorates, whereas the all-weather paint is virtually unaffected. Within 2 minutes, the difference is even greater. All-weather paint is clearly visible, and the conventional pavement marking sample is very difficult to see. Now let's look at these two systems in the field. Videos were recorded at an experimental site where 3 different formulations of all-weather paint were evaluated by drivers, together with the conventional pavement markings and the temporary wet weather tape. In the first pass, all markings are dry. The task of the subject is to determine the direction of taper at the end of each continuous longitudinal marking as early as possible. The taper could be either to the right, left, or both, and sometimes there is no taper, and the longitudinal marking comes to an abrupt end. You can try this yourself as you watch the video and determine how far in advance you can detect the direction of the taper. The distance between consecutive reflective cones is 50 feet. The first sample is a conventional pavement marking with paint and glass beads. The taper at the end is pointing left. Next are 3 experimental all-weather pavement marking samples. The first one, the second one, and the third and last one. Final sample is a temporary wet weather tape, which uses an optical package very similar to all-weather paint. The visibility of all these technologies is comparable under dry conditions, with properly aimed and clean modern headlights. Next are the same pavement markings under rain. Nozzles directly above the markings generate a ½ inch per hour artificial rain for all the markings throughout the rain range. The order of the markings is the same as in the dry condition. The first sample is the conventional pavement marking with paint and glass beads. Notice that the brightness of the sample is reduced considerably under rain. In fact, in the actual experiment, half the drivers entirely missed the taper. The following 3 samples are all experimental all-weather paint. The first one, the second one, and the third one. The fifth and final marking is the temporary wet weather tape. The result of the human factors field experiment with the 5 different pavement markings showed a dramatic improvement in visibility for all 3 experimental all-weather paint samples over conventional paint and glass bead type pavement markings. In fact, the visibility of the experimental all-weather paint markings was statistically equivalent to that of the special temporary wet weather tape under rain. For more information on all-weather paint for work zones and the Highways for Life project, please visit the Federal Highway Project website at www.fhwa.dot.gov/hfl/partnerships/3m.cfm or visit the 3M website at www.3m.com/tss.